Okay, did any groups recall what a vertical line test was for? Raise your hand if your group has an idea about why we ever did a vertical line test. What were we checking for? All of the groups were stumped? Yeah, the vertical line test, because you probably haven't learned the horizontal line test.
Okay, so if like, I think if it went through keywords, it's not a function, whether one it is.
Excellent. The vertical line test was a test for whether or not something was a function. If the vertical line would pass through the whole graph and all that time only cross one point at a time, then it was a function, which meant that every x had only one y, so only one output. But if the vertical line crossed 2 points at once, that meant that x had more than one y, and that's not a function in math. Okay. So a horizontal line test is kind of related to the vertical line test. It's going to test whether something is a function, okay? But it's going to test if your inverse is a function. Okay? So remember, with the inverse, we're switching x and y. A vertical line is x equals a number. So when we switch x and y, if we do y equals a number, we're doing a horizontal line test through our graph, and we're checking to make sure that horizontal line only passes through 1 point at a time. So the general definition for a horizontal line test is a function f has an inverse function if and only if no horizontal line passes through, or intersects, one of the two, cross off intersects, passes through the graph of f more than one time. The horizontal line test says that the function f, the original, has an inverse function if and only if the horizontal line passes through the graph of the original no more than one time. Okay, so I'm going to rephrase it like, sometimes I think the horizontal and the vertical line tests are phrased kind of funny, so like I'm going to rephrase it in my own words. I'm going to say, if a horizontal line intersects the graph of the function f more than one time, then that means the inverse is not a function. You can still have an inverse. It's just that your inverse itself won't pass the vertical line test. It's not a function. So kind of read through that when you're working on your homework tonight, when you're studying for quizzes and tests. To me, I like saying it like if I'm talking about my vertical line test, it's very similar to what Jake described with the vertical line test, that it could only cross one time. If it crossed twice, it wasn't a function, right? So if the horizontal line crosses more than once, then the inverse is not a function. Okay, so just to kind of help you out, and we'll work through this as we go through the notes, I just want to remind you, and we kind of talked about this back in polynomials, but the graphs of, I would call these power functions, so f of x or y equals x to the n. So it could be x squared, x cubed, x to the fourth, x to the fifth, x to the sixth, right, where n is greater than 1. If n is 1, it's linear, it's a line, right, y equals x. So if n is even, the graph will always resemble the graph of f of x equals x squared. What does the graph of f of x equals x squared look like? A parabola. Okay, so we can say y equals x squared. There's our parabola, which basically means that if the n is even, okay, it's always going to be kind of like that U-shaped graph. Okay? And then we had mentioned this back when we were talking about like multiplicities of zeros in polynomials. If you had like multiplicities, if they were bigger than 2, so if you had like a multiplicity of 4 or a multiplicity of 6 or a multiplicity of 8, then your graph I showed you on Desmos, the part where it bounced on the axis, it got flatter and flatter. It still looked like a U, like it was bouncing, but it wasn't as like round as the parabola was, okay, at the bottom. Okay, so as n increases, gets larger, the graph gets flatter at the origin. Okay, so, oh, I say that right there. The greater the value of n, the flatter the graph is near the origin. So I'm just going to draw like a, maybe this is y equals x to 6. It looks like a U-shaped graph. It looks like a parabola. It's not a parabola. It's just flatter at the bottom. Okay, so all even powers have that same kind of shape, U-shape. When n is odd and not 1, when n is 1, it's a line, but when n is odd, like 3, 5, 7, 9, we say that the graph is sort of like that bendy graph. It's not really a straight line. So it looks something like this. Here's x cubed. X cubed looks something like that. Y equals x cubed. And same thing, as the value of n increases there, it gets flatter near the origin. So if I were to draw like y equals x to the 7, it would just be like longer. It would almost look like it was touching the x-axis more than it is, but it only really crosses at 0, 0. It just gets flatter right there. Okay, so like this is y equals x to 7. But all you really need to know is that it's that shape. Because both of these are functions, the u's always pass a vertical line test, and this graph always passes the vertical line test. Okay. Do the u's ever pass a horizontal line test? No. So if you have an even-powered function, the full function, you'll never have an inverse function. Okay. Do the odd ones pass the horizontal line test? Yeah, so these will always have an inverse function. Okay, let's look at that first example. F of x equals x squared plus 2. Can you agree to the graph that I have shown on there? It's parabola, quadratic, and it's going up 2. So the vertex, instead of being at 0, 0, is at 0, 2. All right, is the inverse going to be a function? No. By the horizontal line test, it is not a function. It passes more than one point. So like I'm checking a horizontal line. I cross more than one point at a time. It does not pass the horizontal line test. Just because it doesn't have an inverse function doesn't mean it doesn't have an inverse. We could still find the inverse. Okay? So let's find the inverse. We're going to switch x and y. X equals y squared plus 2. Solve for y. What do you move first? Minus 2 on both sides. X minus 2 equals y squared. Then solve for y by taking the square root, like we did in section 4.5 or 5.4. When I'm solving for y, solving and taking a square root, an even root, what do I have to add to my answer? Plus or minus. So my answer is y equals plus or minus square root x minus 2. Remember we did this on the second blue worksheet for graphing? What shape is that going to be? Would it only be half? Well, we've got a positive square root, and then we have a negative square root, which is just going to be the reflection over the line over the x-axis. So instead of having half of a parabola, you'll have a whole parabola. It's a parabola that opens left. The inverse is a parabola, that opens to the right. That, spell today, opens to the right. Because this is really asking me to graph two functions. Y equals the positive square root of x minus 2 and y equals negative square root of x minus 2. They both get moved right to, so I'm going to graph that. They both get moved right, that's left. Will was agreeing with me, just so you guys know. Right? It was a Friday morning and Will was like, yep. Moves right to, and then I can use for the positive, I'll go up 1, right 1, up 2, right 4. For the negative square root of x minus 2, I'll go down 1, right 1, down 2, right 4. Those are points on the parent graph reflected. Okay, if you want to on your graph, sketch in the line y equals x. Can you imagine folding your paper? The black graph is going to map onto the blue graph. Okay, so they're inverses of each other. Okay? But the inverse doesn't pass the vertical line test, not a function. Okay? The horizontal line test told us that at the beginning. All right, can you try the one down below? Okay, chat it out with your neighbors if you would like. See if you can answer the questions. Is it a function? Is it not a function? The inverse, why or why not? And then see if you can find it. And if you want to try graphing it too, that'd be great. AC, you want to give this one a go? It's on the front side. Nothing changes from yesterday about how you start writing an inverse, right? The rule is still the same. AC, you want to put that on my table? Walking around and I see people telling me, yes, it is a function. It passes the horizontal line test. That's all I have to check. Does a horizontal line only pass my graph one time? Yeah, it does. And then find the inverse. nothing new from yesterday. Switch x and y. See if you can solve. What are you going to do to get y all by itself? You're going to switch x and y. So where this says y equals x plus 3 to the fifth, you're going to change this to be x equals y plus 3 to the fifth. Where did that replace? Yeah. So x to the 2/4 is really a square root. Now you could, like, if you put in a number, you could do it either way, like 4th root it and then square it, or you could just square root it and you get the same answer. So like I think 16 would work really well. You do the 4th root of 16 is 2, 2 squared is 4, 4 16 to the 1/2 is the square root of 16, which is also 4. So they work out both. Yeah, it would be a reflection. I think yours is going, it shouldn't go high to low. It should go low to high.
Oh, so like this one should get very good. Oh.
Okay, first thing you would need to do is 5th root both sides. Okay, when you take odd roots to solve, do you need a plus or minus? No. So this is just going to be y plus 3 equals the 5th root of x. And then subtract 3 from both sides. So y equals the 5th root of x minus 3. Now, we haven't really graphed like the 5th root function very often, if at all. Okay, but you could kind of sketch what that graph would look like. Doesn't this graph, whatever it is, move down 3? Okay, so I would go down 3. And then it's going to have, like notice, doesn't this one look like a cubic function? It's just like flatter at the bottom, at the origin right here. So same thing, like this is going to look like the cube root function. It's just going to be like a little bit more like vertical or more drastic right at the bend. Okay, you could, if you wanted to, like think about some 5th roots. The odd roots will all share that same first 2 points. Like I should go up 1, right 1, down 1, left 1, because the 5th root of 1 is 1, and the 5th root of -1 is -1. So they're going to share those. Okay, it's just kind of like a little bit more like flat, and that's kind of hard for me to do, but it's just a little bit more flat. I wouldn't be able to tell the difference between if you graphed a cube root or a 5th root function, okay, unless you graphed other points. Okay. Okay, and then if you wanted to, like I said, if you want to draw on the line y equals x, does that look like a reflection? Yeah. You could even like check some points. Like this point right here is what? -4, -1. Is -1, -4 on my graph. Yeah. So I've reflected the points. Okay, and it has that same shape. Okay, now on the back side, I have a little box with a note in it, because if you just look down at your 2 graphs that we're going to do next, notice they look like the first one looks like a square root or an even root function, right? And then the second one, it really kind of is like half of a parabola instead of like a whole parabola. So if you find the inverse of an even root function, so like let's say you have a square root or you have a 4th root as your original function. Well, kind of like what Jake had mentioned when we were going to graph our plus or minus square root of x minus 2 on the first problem, he said it would look like a square root function. But really, ours ended up looking like a whole parabola because we had the plus or minus from solving. Okay. If your original function only has one part of this even root, then you'll only have 1/2 of your parabola. Okay, so you might need to restrict the domain of the inverse so that you get 1/2 of x squared, x to the 4th, x to the 6th, the U-shaped graph, right? Like whatever that may be, whether you're doing a 4th root, a 6th root, or a square root. If the even root function is increasing, the domain of the inverse is x greater than or equal to your h value, like if you moved left or right at all in the inverse function. Okay. If your even root function is decreasing, the domain of the inverse is x less than or equal to h. So you'll do all the work to find the inverse, and it will come out to be, if it was an even root, it'll come out to be a power function. Like it'll be x squared, x to the 4th, or x to the 6th. And then you only want one side of that, whether you want the right arm or the left arm, depends on whether your function was increasing or decreasing originally. Okay. So I'm going to flip back real quickly if you want to flip to the front page of your notes with that quadratic one. All right. This side of my parabola that opens to the right is y equals the positive square root of x. So this is like if my root was an even root with a positive increasing. Okay. And these points like 1, 1, or sorry, this is 3, 1. These points reflect, there's 1, 3. Okay. These points reflect to give you the right side of the parabola. So the positive root is the right side of the even function, and the negative root always is the left side of your even function. Now your even function can be shifted left or right, so it'll be wherever your h is, like your left-right movement. Okay? But you'll either want the right side for the or for the positive if it's increasing, and you'll want the left side if it's decreasing. So let me show you how that works in this problem. F of x equals the 4th root of x minus 2 plus 5. Okay, is the inverse going to be a function? Does it pass the horizontal line test? Yeah, it does. It's only going across one point at a time. So yes, the inverse is going to be a function because it passes the horizontal line test. Find the inverse, so I'm going to switch x and y. X equals the 4th root of y minus 2 plus 5. The algebra part of this, finding the inverse, should not be the hard part about today. The hard part about today is, do you have to do anything with domains? So I want to solve for y. I'm going to have to subtract the 5 first. I gotta get rid of the 4th root, so I'm gonna raise both sides to the 4th. Okay. Good news here, I don't want you to do x minus 5 times x minus 5 times x minus 5 times x minus 5. Please just leave it as x minus 5 to the 4th. Okay. So we have x minus 5 to the 4th equals now y minus 2. And then we just need to subtract or add 2 to the other side. So y equals x minus 5 to the 4th plus 2. Okay. So the problem is, if we leave our inverse like this, and I ask you to think about like where would that graph be, what would that graph look like, don't you agree it's going right 5 and up 2? And then if somebody was thinking about the graph of y equals x to the fourth, like the parent graph, remember, isn't that a U-shaped graph that's just a little bit flatter at the origin than a parabola? Okay, so it would be something like that. But if I reflect that 1/4 root over the line y equals x, am I going to get a whole parabola? No. You know, like if I pick points and I say this point right here, this starting point, this is 2, 5, so 5, 2 is on my graph. If I pick this point right here, this is what, 3, 6, so 6, 3 is on my graph. I don't have another super nice point. I'll pick this as like 5 and 6.3. Like a comma. 6.3. So 6.3 and 5 is on my graph. 6.3, comma 5. Don't I only get one side of that graph? So the even root is only giving me the right side because this one was increasing. It's only giving me the right side of the the x to the fourth function. So I would have to, in my answer, restrict my domain. I could say like f inverse of x is equal to x minus 5 to the fourth plus 2 for all x's that are greater than or equal to, because our original graph was increasing, the h value, 5. So I have to restrict the domain so I get only one arm of the parabola. Or the U-shaped graph. I shouldn't say parabola, it's not a parabola. If we don't restrict that and we tell Libby that this function up here, y equals the quantity x minus 5 to the fourth plus 2 is your inverse, she's going to draw a whole round U shape. And we really only want her to draw that one side of it. Okay, so we have to tell her only for x is greater than or equal to 5, which really matches the picture when I reflected the points, right? It starts, the first x that works is 5, and then everything forward. Mm-hmm.
So like when we're graphing those, do you kind of like switch like the numbers?
Yeah.
Okay.
Switch x and y. Isn't that an inverse?
Well, like the -5 and the 2, because like you went,
-5 and 2 isn't anything.
because like for the transformations.
Oh, yeah. Like you might start to notice from the original to an inverse. Okay? Like the k becomes the h, but is looks like the opposite, and the h becomes the k, looks like the opposite, but it really was +2 because you would go right 2. Yeah, you might start to notice those things. Okay, definitely. Okay, last one. I just want to point this out so you don't get like freaked out on homework or on a quiz or a test. Okay. Notice that my f of x over here is a quadratic function, 4 times x minus 1 squared. But then there's a comma for x is less than or equal to 1. So that's saying, like in the picture, the x's that are less than or equal to 1, that 1 is my h value. That's the left side of my parabola. So notice, like this graph would have gone right 1 and had a vertical stretch of 4. And it's x to the fourth, so it would be a parabola or a U-shape, not a parabola, but a U-shaped graph. Okay. But because I'm saying for all x's that are less than or equal to 1, okay, I only want the right side of the graph. okay, which is what you see over here. So the reason that you might see that on a quiz, on a test, or in your homework problem is, even though that's an even-powered function, x squared, it's quadratic, is its inverse a function? Does it pass the horizontal line test? Now, if I take away one arm, it does. Yeah. So, like, on the first problem, when it was a full parabola, I had to say no. But now I can say, yes, it passes the horizontal line test. When you take Algebra 3 or pre-calculus next year and you are working with the inverses, you're only going to do inverses if they are functions. So your book is always going to put that restriction on there. Okay? It's going to say like x is less than this or x is greater than this, and that's just saying use the one arm of the parabola. Okay, find the inverse. X equals 4 times x minus 1 quantity squared. I can ignore the x less than or equal to 1. That doesn't have anything to do with finding the inverse. Oh, sorry, I forgot to change the x to a y, didn't I? Okay, that's a y minus 1 quantity squared. I'll divide by 4 first, so I'll get 1/4 x equals y minus 1 squared. I'm going to square root both sides. Can you do the square root of 1/4? It is 1/2. Yeah. Okay, so I'm going to get 1/2 x equals, and then I'll just have y minus 1. Now, normally we would put a plus or minus over here, right? But that would give me like both sides of my function. Since this one says x is less than or equal, we're going to use the negative even root. That's that box at the top of the page. So we're going to have a negative. Oh, sorry, there's the square root of x, isn't there? Negative 1/2 square root x equals y plus 1. Then add 1 over. Y equals negative 1/2 square root x plus 1. So this graph goes up 1. It's reflected in the x-axis. And it has a vertical shrink. So I'm going to go up 1. Instead of going up 1, right 1, I'm going to go down, and because of the vertical shrink, I'm only going to go down 1/2 and over 1, and then I could go down 1 and over 4. That's what my inverse function would look like. Again, just to kind of drive home that point, that's just a reflection in the line y equals x. Okay? If you check a point, like I had this point 4, 0, 0, 4 is on the other graph. You don't have to do all the graphing today. Okay? You kind of know what shapes the graphs will be, whether they're cubed or raised to an even power, or they're an even root or an odd root. They're going to look like U-shaped graphs, or that graph with the weird bend in it, or the square root or the cube root graph. Okay, your homework assignment, I don't have on here, but it's on your gold sheet.